Hey there, I am Dan Lindeman. This is Python and Serverless Architectures, or Serverless Architectures, a practical introduction. If you were expecting me to say that, then you're in the right place. If that's a surprise to you, now is your chance to get out, because this is the wrong room. You should probably head to a different one. So, a little bit about who I think you are, my intended audience. You're a backend developer. You're probably familiar with Django, Rails, Spring. You write code that interacts with other computers, and it goes on a server somewhere. That's who I think you are. I think you'll get probably the most value out of this talk. If you are a programmer in another context, this isn't not for you. Just I hope that you'll get some value out of it. But this is sort of my intention. So if I did do a thing or assume a thing, sorry in advance. But just kind of wanted to let you know who I think you are. Who am I? I'm Dan Lindeman. I'm a software engineer. I live in Grand Rapids. I work for a small software consultancy based out of Chicago called Spantree. We do data-intensive applications, some SRE work, and then sundry web dev. I would consider myself like a beer that is lightly hopped, lightly opt. That is to say, people have paid me money to do what is called operations work, but I don't like it, and I have some gaps in knowledge. So that kind of sets you up for why I might be giving this talk. So by what authority can I give this talk? The Lady of the Lake did not hand me Excalibur. That never happened. But I have built a recording search backend. So I was using Elasticsearch to search through our company's Zoom meetings. So we record everything we do on Zoom, so we can go back and we can like search and tag. So I built a backend in serverless with that that interfaces with Elasticsearch. I have built for a client, basically an Airbnb backend using serverless. I have also built a couple data ingestion pipelines, so that's like ETL or larger jobs that are like that. I also built the toy for this app, for this talk, but I don't think that counts. So I have done serverless in production at an amount of scale and in anger. So just to let you know who I am. Where we're going with this talk, I think when you're looking at something, especially something that's very buzzwordy, like serverless, you want to make sure you understand the motivations for adopting it, why you would not. So we want to talk a lot about those. Then we'll take a traditional Flask app. And again, I'm assuming you know Flask, but if you know Django or Rails or Spring, they all look kind of the same if you squint. And then we'll translate that into serverless, and we'll see how that knowledge we already have kind of maps into serverless. And then we'll talk about some of the trade-offs, and I'll throw some like tips and tricks and where you want to get started. So there are some ambiguous terms, and any good debate or any good talk starts with definition of terms. I will try my best to differentiate the two. So serverless, little s, because it's our industry's tradition to make very confusingly named things. Serverless architectures are the idea and the pattern of making a system of applications or an application that does not have a server maintained by a particular developer who's doing the application. Serverless TM is a framework that is very useful for making and abstracting away deployments on several cloud providers. So I'll try my best to say serverless framework when I mean the framework, and serverless architectures, little s, when I mean the idea. If I'm talking about a thing or a service or an event producer or something, I'm probably almost going to always talk about the AWS one. That's not the only game in town, but so who has deployed something to or using AWS? Hands up. Okay, cool, like 88%. How about Azure? It's like 14%. Google Cloud Platform. Cool, okay, so the numbers work out, statistics work out. That's exactly what I was expecting to hear. So when I say it's on AWS, I'm in your mind. I'm just using statistics. Great, so let's get to the meat of this. No matter what client I talk to, whether they're an enterprise or whether they're like a mom and pop shop, they want to make sure that they're not throwing money away on software or software expenses. They want it to be cheap. So remember way back when cloud was the word that everybody thought was, this is so dumb, and we migrated to the cloud anyways. Why did we do that? The reason we did it was because it was cheaper, right? So instead of having to buy a rack or two, it's $50,000, you rent it from Cisco or Dell, and you bring it in-house, and you have to have the cooling and the power. Oh my God. We didn't want to do that anymore. And we said, let's not do that. Let's just pay somebody else. Let's borrow some from Lord Bezos and see if he'll let us run on his machines. So when you think about serverless in this way, I would think about it that exact same way. So even if you're provisioning an EC2 instance, so it's like a cloud-hosted virtual machine, you're still paying for idle time, right? So serverless architectures or functions are priced per invocation. So when you think about how cheap is it, what is the barrier to entry, you can ride the free tier. Like it is the natural progression of, not paying for your infrastructure up front. So this is very appealing for clients that I work with, or if you're a startup yourself, in terms of cost. You might also be motivated by this graph. So this is a picture of my self-confidence. If you're lightly opt, so this is my front-end perceived skills, my back-end perceived skills, I've rated myself using completely no science or anything. So I'm about a half on ops, right? 5 out of 10. Not the best, but that could be you. That could be motivating for you. Other thing is you don't know how many users you're going to have. It could be a bustling, application that goes viral, or it could be a ghost town. Has anybody ever written an application that had more or less users than they thought? Yeah, it's mostly the one, right? Other things I don't know. I don't know how to maintain infrastructure. I will throw it right out there. I don't know what it would mean to maintain the life cycle or the lifetime of a piece of infrastructure. That's not what I do. That's not what I have expertise in. So I will let the people who are very good at maintaining and updating infrastructure do that. I also don't know much about security. I know how to do application level security, but I don't know about the things underneath it. I trust a lot of the things underneath of me. And I think that's very common. It's scarily more common than you might suspect. But if you don't know this, and you do know application security, okay, so serverless is appealing again, right? There you have a service level agreement of the responsibility level of your cloud provider versus you. OS level patches, security updates, things like that, that they're going to do. So it's also a good motivation. And I want to return to money again, because when you're creating the architecture or infrastructure definition, you do have to worry about how much things cost. And all of the providers that I've looked at their documentation are very upfront about how much it costs per invocation, per use, per read provision, per write provision, everything. So if you can do a little bit of napkin math and say, you know what, if we have 20,000 users, this will cost us, $1,000 a month. That's really good to see. That's good to know up front. It's just better to have that information earlier. So it's another thing that might motivate you. The final motivation that I really enjoy is the surface area of things that can invoke functions. So the heart of serverless architectures is actually the event producers. So this is the Amazon page of things that make events. We'll talk a lot about events. Events that can trigger a Lambda or a function in this case. Each of these, if you click in, has minimally 4, so like create, read, update, delete. But many of them have 20, 30, 40. So this is just the AWS ones. And as a note, HTTP events are also possible sources and triggers. So, if you can make something that makes an HTTP call, you have yet another producer. So the kind of combinations you can come up with are really, really cool. So people often kind of look at lambdas and they think like, oh, functions, this is so silly. Like, can't I just write any application code? What is the point of this? I really think that lambdas kind of get an undue amount of blame. They are more, to me, the glue. And when I'm thinking about using a serverless architecture, I'm thinking about the event producer. So I'm confident that I could write code that behaves like a Lambda. I could make an application that behaves like a Lambda. That's not, to me, that's not that crazy. The distribution is crazy. But when I look at the event producers, I can't, and my company can't make Dynamo. We can't make a durable storage engine like S3. I'm not going to. That would be a reckless use of resources. Companies like Google, Amazon, and Microsoft are doing that. So they're very good at it. Let's ride with what they're doing. If you were to take probably nothing else away, if you were going to like snap a picture or just remember this, I think Kelsey Hightower has a great opinion on what serverless means and how to sort of like change it from buzz to, oh, this is just like another tool. So if you take nothing else away from the talk, you will have read this tweet, hopefully. We'll meet serverless plenty. This is the serverless framework. This is their homepage about what they interact with. So if you use any of these, you can also use this framework that I'm going to be talking about. It's quite a lot. So this is the promise. And we're basically here, if you're serverless curious, which you might be because you're here, you want to know, does this work? And I have a friend, Dr. Tsoukalos, who will explain. Thank you, Dr. Tsoukalos. So a lot of people get really worried, too, when you talk about serverless architectures, about vendor lock-in. And it's terrifying, right? They're like, I want an open platform forever. I don't ever want to choose a thing. I want to take my configs, have configs, we'll travel. You don't quite get that in serverless architectures because you are, like I was talking about earlier, you are binding yourself to the event producers that are made by these companies who make really good event producers. So when you're like, I want to use Dynamo, I want to use S3, it's going to be hard to avoid vendor lock-in. I'm really glad to take time in the hallway and hop on a soapbox and we'll talk about vendor lock-in, but that's not this talk. I've hopefully whetted your appetite for serverless. So let's talk about ice cream. This is my toy application where I introduce you to the toy and then we're going to kind of look at it. So at Spantree, we love ice cream. We love it a lot. We keep a database. This is what the database looks like of our favorite flavors of ice cream. This is very secret material to us. We're very passionate about ice cream. So as a backend developer, whenever I have a piece of data, I put a backend API in front of it. So here's our API. If you get team, you get everybody. You get all these, I spill the vanilla beans about what flavors we like. And if you look up a specific person at ice cream/person, you can get, for example, if you were to do ice cream/Shane, you would find out that Shane's favorite ice cream is cookie dough. So here's what it looks like in Flask. This is the thing that's very familiar to you. You have your app.route decorator. That's doing the HTTP routing for you. If you don't pass anything in, it assumes it's a GET request. You may or may not be familiar with the @jot required. I didn't make up jot as the pronunciation for JSON Web Token, but that's what it is. I'm sorry. Then you have to do the method below it, and it can take in the arguments from person, it maps to the function that's below it. And then if you want to use jot, the jot required package in Flask, you have to make an identity and an authenticate function for authorization and authentication backwardsly, respectively. There's a little bit of a hullabaloo about configuring it and giving it a secret. I probably wouldn't do this in plain text in production, but you know what it's looking like. Cool. So now what? Well, we bundle it up. We Heroku deploy it. Actually, who has worked with Heroku? Who has deployed a thing to Heroku? Oh, so you're already serverless devs. Got it. A dyno is an abstraction around a server. So you were already a serverless developer, and you didn't know it. If I were going to compare what it's like to deploy serverless things from the command line, that's the closest parallel that I can think of. Heroku's great about that. The Heroku tool belt and toolkit is very much like the serverless one. Let's talk about serverless. So we're going to do the exact same API, and we're going to look at it in serverless. So the main, one of the main shows in serverless, the framework, is this serverless.yaml. So it is a YAML-based abstraction layer around the deployment strategies for several cloud providers. Whew, what does that mean? So we're going to look at a serverless.yaml, and it's going to define, serverless will map it to, in AWS's case, CloudFormation. CloudFormation is a template language for defining resources and tying them together and putting them into a CloudFormation stack. Cool, so this is the very first part of our application. So like when you get a new puppy, you have to name it. And I highly recommend naming it because if you don't name it, serverless is very uncreative, or not very creative, and it will name this, for instance, it would name this one AWS-Python 3.6, which is fine until you make, you get the serverless bug and you make a second one because it's making a CloudFormation stack. If you have two CloudFormation stacks with the same name, you can't do that. Plus, it would be ridiculous to have two puppies both named Python AWS 3.6, right? Like, that would be a ridiculous thing to have two puppies named that. The next part, so if we were looking to serverless to save us from vendor lock-in, we are now down at line 4 of this YAML, and we're going to lock ourselves into a provider. So we got 4 lines of YAML that we didn't have to lock ourselves into a provider. Whew. Here we chose AWS, and I'm using the Python 3.6 runtime. You cannot do polylinguistic serverless deploys. That's just a thing that you can't do yet. So here I chose Python. I'm at PyOhio, so I think I'm at home. Cool. Moving down the YAML, you have a plugin section. So this plugin allows me to use Python requirements.txt to let serverless know how to bundle it up and send it up to an S3 bucket and deploy my code. The next one is serverless KMS secrets. I love this. It uses Amazon's key management service for doing secrets, so I don't have to have secrets on my computer, and I am totally indemnified from any data leaks that happen. So yeah, you make your plugins if you're going to use extra. There are a lot of them. These are just two that I wound up wanting to use for this project. Cool. So now we're actually going to get to define our functions. So we have a functions section of the YAML. And so this one says this function is called team. It lives in, its handler is the code that will be called when this function is invoked. So it'll live at handler.py in a function called team. So you'll see handler.py def team. So then this is its equivalent in Flask. So that's the Lambda, that's the Flask. Yes. So this responds to HTTP events. So this events list is all of the events that this responds to. So this says, I know about HTTP events. If you get an HTTP event at the path /team and it's a GET request, use this code. We're going to look at the other one. So this is the lookup function. So at ice cream and then a path parameter person. It's very similar. The only difference for this one is that the request has a little bit of decoration on it. So the request is going to have a path parameter, and it's going to be called person, and it will exist. I actually don't know what the true does, but I think it just made YAML happy. The Flask equivalent is our def lookup. So we're seeing these kind of mapped together, right? Like we're seeing the HTTP routing, the verbs that are OK, the path that's OK, some parameters that are OK, and then where does the function live? Now in Python, it's a decorator, so the function lives right next door. But in serverless, it lives in the handler.py. Cool. So when we did the JOT required aspect of our application before, we had to do a little bit of a song and dance about what are the secrets, where does the authenticator live. With the JOT required plugin, you have an auth endpoint that gets exposed. It will give you back a JOT if it thinks that it knows who you are and you're allowed to do whatever you're allowed to do. Just like that, our authorizer for serverless will be an API gateway that gets put in front of every other request that we do. So if you try to call out to, in this case, handler lookup, we use these 3 extra lines down here, the authorizer lines, to point that function, because the authorizer is just another Lambda, right, another function. We point it to that and say, if anybody tries to talk to you, you tell them to talk to the authorizer first. The authorizer is responsible for giving a policy document back. In this application, I want to make a huge caveat. I am conflating authentication and authorization, which is a horrible, stupid, nasty thing to do, and don't ever do it. But I am, because if I know who you are, you're allowed to know what my favorite flavor of ice cream is. That's my reason that I can do that. Cool. So let's look at that handler.py. What does it look like? It looks very similar to our Flask code, right? It has a function called team. It has a function called lookup. It's got a function called authorize, which in the other one we said were identity and authenticate. But they all have the same path or the same arguments, right? Event and context. If you've written lambdas before, who has written a lambda before? So this looks pretty familiar. You always get 2 arguments passed into you. The event, so that's information about the thing that invoked you as a lambda. We're pretending to be lambdas right now. And then the context object contains context information about the runtime of your lambda. So it'd be like kernel information maybe, or local time, or the time this lambda has left to live, which would be compelling information in life in general if we could all have the context to know how long you have left to live. Sorry, we got a little deep and philosophical there. So when you're writing an authorizer in particular, there is a little bit of a song and dance around doing context.succeed and context.fail. And you're going to run into this. If you try to write an authorizer, your own custom authorizer, you will run into this, guaranteed. And it's kind of unfortunate because if you fail to authorize or authenticate, you will get a 403 unauthorized error, right? So if you're unauthorized to do a thing, the HTTP code is, or the status code is 403. If you aren't familiar, Amazon, if a resource doesn't exist, instead of giving you a 404, it will give you a 403. The reason being, it would be much easier for bots and crawlers to figure out where people's resources lived if it gave a 404, like, no, there's nothing here, and they could just move on. Whereas if everything that doesn't exist gives you a 403, just like the things that you aren't authorized to see. So it's kind of clever, but you're going to run into it. Just look back at the talk after you run into it and be like, ah, Dan said. So this is what we get, roughly. We get a client making a call to API Gateway. API Gateway says, no, you got to go to the authorizer function. Authorizer function gets called, gives you a policy document back, and then you're in. Then you can access the things that the policy document says, this is OK to access. This is just ripped from the normal Lambda custom authorizer developer guide. Cool, so now what? On our command line, we run SLS deploy, just like the promise. It goes up, it lives, a CloudFormation stack is deployed, all of our Lambdas are deployed, all of our, if we specified Dynamo tables, if we did anything, it's all up there now in its own stack. Perfect, it worked. The last thing it gives you is a list of URLs and other ways to find those resources. So in Amazon, it'd be like an ARN, like where does this thing exist now? So you can go find it. Cool. So let's take a look around what we might expect the CloudFormation stack to look like. So in our application, we defined team, lookup, and authorize. OK, so we have 3 resources that we've defined. Cool. So we expect probably 3 resources were deployed to AWS. Here's what it looks like. OK, so wait, we've got 3, 6, 9, 12. OK, so I can at least figure out 6, because we had to put an API gateway in front of all the Lambdas. So authorize took team lookup and their API gateways. What in the world else is going on here? Well, it turns out there are also IAM roles that get deployed. There are S3 buckets where your code actually gets bundled and put to. There are a whole bunch of fun things. There are AWS Lambda permission objects. So it actually deploys something like, I think the smallest thing I've ever deployed, which was 1 thing, had 6 resources deployed. This will be interesting later because there are limitations. And serverless doesn't tell you about any of those. So what does it look like otherwise? I mean, all of the piping has been done for us. So on this side, we see our API gateway definition. It's great. Then we see our authorizer in the middle, and then we see the Lambda that is being proxied to here. It's very sensible. This is probably the best UI that Amazon has ever produced. It's a pretty low bar, but they got over it. Logging. Logging is done per Lambda. That's a normal Lambda feature, not a bug. Right now, that will be OK, especially if you have a small application. But when your application grows to many more Lambdas, and you want to find out where things went wrong, you're going to go hunting through CloudFormation logs, CloudWatch logs for a long time, looking at each different function. So imagine if in your Django app or your Flask app, every function logged to a different location. Yeah, it's not the best. There are some attempts to fix this. Humio is one out of Amsterdam, I think. And then Amazon is working on X-Ray, which should allow you to do like log aggregation and log tracing. But it's not beautiful. I did mention that resources and events are kind of the main show. And unfortunately, I chose a REST API because not saying REST, it's a HTTP API because it would be familiar to look at. But I wanted to make sure we could see like an example of this is a Dynamo table being provisioned. So it's a little bit more complex. It's actually not that much prettier than what you would do in the console, except you can put this into Git. And you can't put your actions on a AWS console into Git. As a fun side note, and if somebody wants to hack on this later, you actually can use Flask in serverless, or you can use Flask or Django in Lambdas. You can use Spring and Lambdas. There's no reason you couldn't just take your code and put it inside of the Lambda. I haven't done this, but you could do it, and it would be kind of fun. Great. So I think I've painted kind of the picture of what it looks like, how your application changes, like the actual mechanical physics of what you need to write. So what do we get? We get dead simple deploy. We get scale out for free. We get linked connections between all of our resources for free. We get fixes to features we didn't know we wanted to be able to do. So you can change one Lambda at a time, which is really cool. It's very hard to do that with a Flask app, to change one function and one function only without rolling out. But you can totally do that in serverless. You didn't know you needed that, but now you have it. Also, selfishly, I work remote, and I like chances to get to work side by side with my colleagues. So when we were doing this, I know I've talked a lot about AWS-specific resources, and that might be intimidating, tough, a little dense if you're not familiar with that landscape. But what I would recommend, if you wanted to try this, learn some of the basics of whatever cloud provider you're going to be comfortable with. So we did an AWS learning path where we went through the videos on a Cloud Guru, which is a really lovely website. I'll have a link later. And we all sought AWS Certified Developer accreditation. And so now we all have it because we worked together to learn the underlying platform. It's super important, and it's really cool because they'll tell you about like what is possible, what they've made, what event producers they're creating for you to pipe together. So selfishly, I get to spend more time with my colleagues learning. But we did allude to several points where maybe this wasn't the best. So what are some of the things that are not so great? Well, you get scale out, but you actually can't scale up very hard. There are limitations on how much compute a function can use. And if you have a computationally expensive operation, it will die, and it will run out, and it will just not work. Or you have, for instance, 5 minutes to live. I can imagine training a model would take a little bit longer than 5 minutes. I can imagine running web scrapers taking more than 5 minutes. It's pretty easy to imagine situations that this would not work very well for, right? What else do we get? Oh, testing is very hard to do, or is not super obvious how to do it, because I don't have Amazon's infrastructure on my MacBook. I mean, it's a beefy machine, but it's not that beefy. So the testing story is not that great. It's also a leaky abstraction around the deployment language for whatever cloud provider you're working with. So for instance, if you want to refer to something outside of your stack, you have to learn CloudFormation. And at that point in time, you know CloudFormation, and you probably didn't need serverless. But it's OK. The other thing is that all languages are not created equal. Luckily for us, Python is a first-class citizen in the world of the cloud and in the world of serverless. For my money, Go and Python are the fastest. If you're looking for speed, Node comes in a very, very close second. But then like C# and Java, which are also supported languages, are very slow. You will sometimes get up to like a 5 or 6 second warm-up time while the Lambda is booting up the JVM or the CLR, and then it goes, which is a limitation. We kind of thought of the examples already of what we would never do in serverless. This is a great blog about when you wouldn't use serverless from the serverless framework. Read it. They have some really compelling reasons why you should not do this. Hope stepping on a router is probably fine. Some pro tips. This is like the next section of just things that I've seen and things that my team has done using serverless. So one thing that was really cool is we built an API that the Airbnb backend, and we had hit the limit of CloudFormation. So it limits you to 200 resources, and we deployed more than 200 resources, as you do. And so we realized we could actually split these along service lines. So we did service-oriented architecture. by accident, on purpose. We split out our APIs into the services that they were. And you can do that with serverless architectures because you can just cut and paste out the YAML and say, you live over here now, you live over here now. A lot harder to do that in Django, a lot harder to do that in Flask, Rails, in a traditional backend. Some things that I really like. I love Dynamo streams. So way back when, Dynamo streams are whenever a Dynamo record is created, you can kind of dangle a Lambda off of that and do something with it. I spent about 2 months setting up change data capture on MariaDB. It uses like binlog replicas and Kafka, and still it upserts something to Elasticsearch. Oh my God. We wrote this in like 4 lines of YAML. It's great. So if you want to use, like, get that pattern of whenever something changes in a database, do something with it, Dynamo streams are cool. I also like KMS, because KMS, we already talked about earlier, just lets me kind of deal with secrets in a way that's way better than living in a .env file somewhere. Oh, this is a great trick. So the resources section can actually refer to other files and do string interpolation. So what I do is I'll usually write all of my functions, and then the resources live in a different place. So they're kind of like, you know, here's the dynamo.yaml, and it's just another serverless YAML that is just defining the resources. So this works. Then you define your API gateways, you deal with all the routing and who's authorized by what. It's super convenient, and if you're going to use this in sort of larger applications, I highly recommend doing it. I would also use SLS, or invoke local. So it is a way to at least check your functions. In general, for testing, what I find to be best is you make a really thin Lambda, which is to say the Lambda gets the event in the context and then immediately passes just the event off to your real business logic. It's much easier to test this way because just like when you're using something that relies on an HTTP client, you don't test that HTTP works, right? So I'm not going to test that Lambdas can be triggered. That's the job of Amazon. I presume that it works, and I'll write my business logic in the event handler business logic code. So that's just a kind of pro tip for testing. Cool. So, it's too much GIF, too much Jared. We're going to move to serverless, right? I think that's pretty clear. We're all now in the world. I hope that you can kind of see it as a valid choice for your architectures. It's not the be-all, end-all. I've shown you probably one of the least exciting examples of it, but there are much more compelling examples. Think about all of the event producers and the combinations and permutations you could make cool things with. We know reasons why. We know reasons not to. We know why your company or your clients might be interested in this. It's not a silver bullet. It's just another architecture choice. If you want to get started, I really like Serverless Stack. It does what I do, but it has tutorials. They're great. And then I also recommend a Cloud Guru. They're these fun Australian brothers, I think. And they always begin every video with like, hey there, Cloud Gurus, which is my terrible Australian accent. It's very fun. Highly recommend both of those for getting started. Other than that, thanks so much, PyOhio. You've been wonderful. I work better in